When we think of stars, we often picture small twinkling specks in the night sky. This is the way we observe them from Earth. However, stars like Betelgeuse are vastly different. In fact, Betelgeuse is so gigantic that it far surpasses our Sun in size. This star has perplexed scientists for a long time. Recently, though, new developments surrounding Betelgeuse have raised more concerns among researchers. In this video, we explore the latest updates about Betelgeuse, including its anticipated end as predicted by the James Webb Space Telescope. We will also discuss how these events might affect both our galaxy and life on Earth, as explained by physicist Michio Kaku. Betelgeuse is a fascinating cosmic wonder, an enormous star that has intrigued astronomers for many years. The initial discovery of Betelgeuse was made by the Greek astronomer Tycho Brahe. This star is so vast that it can be seen in the evening sky from Earth, particularly during the winter months. If you're passionate about astronomy, you've likely heard of it. Betelgeuse is the bright, reddish-orange star that marks the upper left shoulder of the Orion constellation. It's an ancient star and one of the most luminous objects in the night sky. However, its brightness is not constant and fluctuates over time. This variability is one of Betelgeuse's most interesting features, but it is not the only remarkable characteristic of this star. Most of the stars visible to us are extremely far away. The closest star, Proxima Centauri, is located 4.2 light-years away from Earth. If you're not familiar with the concept of a light-year, imagine traveling at the speed of light for an entire year. Light moves at approximately 186,000 miles per second, and in 1 year, light travels billions of miles. So when we say Proxima Centauri is 4.2 light-years away, we mean it is billions of miles from our planet. However, there are stars like Betelgeuse that are even farther. Betelgeuse lies about 600 light-years from Earth. That means if we could travel at the speed of light, it would take us 600 years to reach it. Unfortunately, we are not yet capable of traveling at the speed of light, not even with our fastest spacecraft. Despite this great distance, Betelgeuse still shines brightly in our night sky. You may wonder how Betelgeuse can be so luminous despite being so far away. The answer lies in its unique features, such as its enormous size and incredible luminosity. Betelgeuse is approximately 500 times larger than the Sun, and its radius is believed to be several times that of our Sun. When observed through advanced telescopes, Betelgeuse appears more as a disk than a tiny point of light, unlike most other stars. This phenomenon is believed to be caused by the reactions happening in its outer layers. As for its mass, Betelgeuse weighs somewhere between 12 and 19 times the mass of the Sun. A single solar mass is equivalent to 2 times 10 to the power of 30 kilograms, but astronomers cannot precisely determine Betelgeuse's mass due to the lack of other planets or objects orbiting it, making direct measurement from Earth impossible. The fact that Betelgeuse is many times more massive than our Sun makes it truly exceptional. Betelgeuse's brightness ranges from a magnitude of +0 to +1.6. In simpler terms, it is about 16,000 times more luminous than our Sun, earning it the title of a red giant. However, its brightness is not constant. It fluctuates due to the pulsations within the star. When Betelgeuse expands, it becomes brighter, and when it contracts, it dims. These cycles can last anywhere from 10 to 100 days, or sometimes even longer. Another fascinating feature of Betelgeuse is the presence of dark magnetic spots on its surface. These are areas where the magnetic field is much stronger than usual, hindering the flow of hot gases to the surface and cooling those regions. Betelgeuse has far more of these magnetic spots than the Sun, which is why it is cooler despite its greater size and luminosity. While our Sun also has dark magnetic spots, Betelgeuse's spots are significantly larger and more numerous. For perspective, some of these spots can be twice the size of Earth. Betelgeuse also has a magnetic field about 1,000 times stronger than that of the Sun. This magnetic field creates spiral or arc-like patterns on its surface when observed through a telescope. The surface temperature of Betelgeuse is approximately 3,500 Kelvin, which contributes to its low energy output and faint red color. Interestingly, Betelgeuse wasn't always a red star. Around 100,000 years ago, it had a yellowish hue, similar to our Sun. Over time, it transitioned to an orange and eventually red color. Approximately 10,000 years ago, Betelgeuse began evolving into the red star we see today. This transformation led scientists to conclude that Betelgeuse is aging. Betelgeuse emits up to 10,000 times more energy than the Sun. Had it been closer to Earth, it would have outshone the Sun. If it were any nearer, it might even be visible during the day. However, due to its enormous size, if Betelgeuse were to replace the Sun, it would engulf Earth and the nearby planets. Even if Betelgeuse could match the Sun's energy output, it would still radiate far more energy, making it even more powerful than our Sun. Despite being 600 light-years away, Betelgeuse is still visible to the naked eye, which is remarkable. Our Sun, located just 8.3 light-minutes away, is much brighter than Betelgeuse due to its proximity. Betelgeuse is one of the largest stars we know, with a size around 500 times that of the Sun. If it were placed at the center of our solar system, Betelgeuse would easily encompass the orbit of Jupiter. This immense size causes Betelgeuse to appear as a disk when viewed through powerful telescopes, unlike most stars, which appear as tiny points of light. Although Betelgeuse is not the most massive star in the universe, its mass ranges from 12 to 19 times that of the Sun, depending on various estimates. One of the most intriguing aspects of Betelgeuse is its variability in brightness. Unlike the Sun, which remains relatively stable, Betelgeuse experiences irregular fluctuations in brightness. These fluctuations are believed to result from the pulsations within the star. At its brightest, Betelgeuse is 16,000 times more luminous than the Sun, but during its dimming episodes, its brightness can drop significantly. These variations have fascinated astronomers for centuries and provide valuable insights into the star's life cycle and characteristics. The surface temperature of Betelgeuse is relatively low for a star of its size, around 3,500 Kelvin, which gives it its reddish-orange hue. As a red giant nearing the end of its life, Betelgeuse has depleted the hydrogen fuel in its core and is now fusing heavier elements. This fusion generates energy and causes the star to expand. The star's surface is also marked by dark magnetic spots, much larger than those found on the Sun, which restrict the flow of hot gases from the interior to the surface, leading to cooler regions. Betelgeuse has been studied by astronomers for centuries, with various cultures, including the Greeks, Egyptians, and Chinese, recording its position and brightness. In Arabic cosmology, it is referred to as Yad al-Jaza, meaning the hand of the giant. Recently, Betelgeuse has attracted even more attention due to a series of dimming events that began in late 2019 and continued through mid-2021. During these dimming events, the star's brightness dropped to unprecedented levels, raising the possibility that Betelgeuse might soon go supernova. A supernova is an explosive event that occurs when a massive star runs out of fuel and collapses under gravity, triggering an enormous explosion that can outshine an entire galaxy. If Betelgeuse were to explode as a supernova, it would be one of the brightest objects in the sky, even visible during the day. The idea of Betelgeuse going supernova has captured the imaginations of both scientists and the public. Astronomers continue to monitor the star using advanced telescopes and space-based observatories to learn more about its behavior and evolution. Betelgeuse's status as a red supergiant provides important insight into the later stages of stellar evolution. These stages involve the fusion of heavier elements in the star's core and the dispersal of these elements into the interstellar medium. Studying Betelgeuse helps astronomers understand the complex processes that shape our universe. When we look up at the night sky, we often see stars as tiny, distant points of light. However, stars like Betelgeuse, located in the Orion constellation, are much more than that. They are among the largest and most famous stars visible from Earth, and their stories are filled with cosmic drama. Betelgeuse, about 600 light-years away from Earth, is a red supergiant star in the final stages of its life cycle. Its diameter is estimated to be 500 times larger than that of the Sun. If placed in the center of our solar system, Betelgeuse would extend far beyond Jupiter's orbit, dwarfing our Sun. Despite its immense size, Betelgeuse's brightness fluctuates significantly. It is 16,000 times more luminous than the Sun at its peak, but dims considerably at times. The dimming observed in late 2019 sparked public curiosity about whether Betelgeuse might be preparing to explode into a supernova. Astronomers have been intrigued by Betelgeuse's behavior for years, but the dimming in 2019 and 2020 was unprecedented, making Betelgeuse one of the dimmest stars in the Orion constellation. Some speculated that this dimming could be a sign of an impending supernova. However, recent studies suggest the dimming was likely due to a dust cloud forming around the star. Betelgeuse often expels material, and sometimes this material clumps together to form dust clouds, obscuring the star and reducing its brightness. Although the dimming cloud temporarily reduced Betelgeuse's brightness, the star itself remains active, and there is no direct evidence to suggest it is on the verge of exploding. To understand Betelgeuse's significance, we must explore its life cycle. Like all stars, Betelgeuse began in a molecular cloud of gas and dust. For most of its life, it fused hydrogen into helium, much like our Sun. However, because Betelgeuse is far more massive than the Sun, it has exhausted its hydrogen fuel and is now fusing heavier elements like carbon and oxygen. This fusion process generates more energy, causing the star to expand and evolve into a red supergiant. Stars like Betelgeuse end their lives in dramatic supernovae. When they can no longer sustain fusion in their core, gravity causes them to collapse, triggering a massive explosion. This explosion will outshine the entire galaxy for a brief period. If Betelgeuse were to go supernova, it would be visible during the day from Earth, despite being 600 light-years away. This event would scatter elements like iron, calcium, and oxygen into space, enriching the interstellar medium and aiding in the formation of new stars and planets. Supernovae play a crucial role in creating the elements that form planets, including Earth. After a supernova, the star's outer layers are expelled into space, and its core may collapse into a neutron star or, if massive enough, a black hole. While Betelgeuse's eventual supernova will be a spectacular event, there's no need to worry. The explosion is expected to happen within the next 100,000 years, so it won't affect us anytime soon. Even if it were to explode tomorrow, the distance between Earth and Betelgeuse is so vast that its explosive energy wouldn't reach us in a harmful way. Betelgeuse's future supernova, while fascinating, will not have any immediate impact on Earth. The 600 light-year distance means that the explosion wouldn't harm our planet. However, it highlights the immense power and dynamism of stars like Betelgeuse and how their life cycles contribute to the ongoing evolution of our universe. The eventual explosion of Betelgeuse into a supernova will be a breathtaking event for astronomers and anyone fortunate enough to witness it. Though still far off, this event will be an important moment for understanding stellar life cycles, as the death of massive stars like Betelgeuse plays a crucial role in distributing heavy elements throughout the galaxy. These elements are key to the formation of planets and even life itself, underscoring the interconnectedness of cosmic processes. Astronomers are closely monitoring Betelgeuse, using advanced telescopes and space observatories to track its brightness, pulsations, and any changes in its behavior. They continue to study its fluctuations, hoping to gain more insights into the star's nature. Understanding how Betelgeuse and other stars behave provides valuable clues about the forces that shape our universe. The study of these stars also enhances our knowledge of stellar life cycles, the dynamics of galaxies, and the processes that lead to the formation of planets and other celestial bodies. Observing Betelgeuse also offers insights into the early universe and the origins of the elements that make up everything we see around us. In the grand scheme of things, while Betelgeuse's supernova may not occur for another 100,000 years, its eventual explosion will leave a lasting legacy on our understanding of the cosmos. For now, we can continue to marvel at its variability, its massive size, and its crucial role in the grand story of the universe. Stars like Betelgeuse remind us that the universe is far from static. There is always movement, change, and mystery unfolding across vast distances. In the end, studying these incredible stars not only captivates us with their power and beauty, but also deepens our understanding of the forces that shape the universe and everything within it.